Hello everyone, my name is Juan and welcome to this week's video. Today I want to talk to you guys about geometric sequences, or we can call them geometric progressions. Now question number one is, what's a geometric sequence? It is a sequence where each term is found by multiplying the previous one by a fixed number called the common ratio. And when we're talking about geometric sequences, we have to be comfortable talking about two specific terms. The first term is called the initial term. So if in geometric sequences each term is found by multiplying the previous term by a specific number, then we must know at least the first number, so we can multiply it by a specific number and then we calculate the second one, and then with the second one we're going to calculate the third one, and so on. In other words, we have to know at least the first number, right? And the second term is the common ratio, which is the number by which we're going to multiply each and every single one of the numbers of our sequence to find the next one. Now let's see how this goes. If we have a sequence that has an initial term equal to 1 and a common ratio equal to 2, then the second term is going to be 1 times 2, which is equal to 2. And then the third term is going to be 2 times the common ratio, which is 2, so it's going to be 4. The next term is going to be 8, and so on. Or we could have another sequence that has an initial term of 3 and a common ratio of 4. So the second term will be 3 times 4, which is 12. And the third term will be 12 times 4, which is 48, and so on. However, not all the geometric sequences will be increasing the whole time. We could have a geometric sequence that has an initial term of 24 and a common ratio of 1/2. So the second term would be 24 divided by 2, which is 12. And the third term would be 12 divided by 2, which is 6. And the next one would be 3, then 1.5, and so on. You could think about that sequence as a stick that it's 24 inches long, and then you divide it by 2. And then you get like a 12-inch stick, and then you just keep dividing it in 2. So half of it would be 6 and half of it would be 3, and so on. Now let's talk about the nth term. The nth term refers to a number in a particular position of a sequence that you want to know about. So for example, you have whatever sequence you want and you want to know the 30th term. So that 30th term would be your nth term. And your position n equals 30. So it would be like first term, second term, third term. Those are like your n numbers. Now let's come up with a formula that will help us find the nth term of a sequence. So we have the initial term of our sequence, which is going to be called a. For the second term, we're going to take the first term and multiply it by r, which is our common ratio, and that's it for our second term. And then for our third term, we're going to take the previous one, which is a times r, and we're going to re-multiply it by r. So we're going to have a times r again. And as we progress in our sequence, we're going to keep adding r's. If we were to simplify that expression, we would have a as our initial term, and then a times r for our second term, and then ar squared for our third term, and the exponent of r would continue increasing as long as we increase in our sequence. Finally, this pattern tells us that the nth term of a sequence is going to be a times r to the n minus 1, being a our initial term, r our common ratio, and n the position of the term we're looking for. So let's go back to the first example that I gave you, which was a sequence of 1, 2, 4, 8, 16, etc. And let's calculate our fourth term, which is 8, right? So applying the same formula, we would have 1, which is a, times r, which is 2 to the power of 4 minus 1. Because 4 is our fourth term, that's the position that we're looking for. So 1 times 2 to the 3 is 8, which is the number that we were looking for. Now, how do geometric sequences behave when they approach infinity? They don't depend on the initial term, they depend on the common ratio. So if the common ratio is 1, then the entire sequence will be constant, because we would be multiplying our initial term by 1 over and over again. So it would be a constant sequence. If the common ratio is equal to -1, then the sequence will alternate in between positive and negative numbers. So if the initial term was 3, then it will alternate in between 3 and -3 over and over again. If the common ratio is in between -1 and 1, so it's a fraction, then the terms will be decreasing over and over again until when the sequence approaches infinity, they will tend to be 0. Finally, if the common ratio is greater than 1 or less than -1, then the terms will be increasing over and over and over again until they approach like infinity, and we would say that the sequence diverges. So that was it for this video. I really hope you guys enjoyed it, and if you did, please don't forget to give it a big thumbs up and subscribe if you haven't yet. Don't forget to share it with all your friends, and I'll see you all in my next week's video. Bye.